Welcome to Robominions.in AI interview preparation app. Before heading to the topic, I'd request you to watch this video on your laptop. So we need a bigger screen so that you can clearly see the code and each stage of the code. So request you to watch it on your laptop and also download we have the Robominions.in AI interview preparation app. Please visit the website Robominions. Please visit the website robominions.in and download latest version of the desktop interview preparation app. It runs on your laptop. So download for Windows OS and click on download anyway and start running the app. So I hope you have the setup ready. Then if that is the case, you can pause the video and get the setup ready and then come back to the video. Yeah, so let's move forward. Watch the video once and then you can try clicking back and next button to control the code on laptop and on the app, and you can revise the concept. So the whole idea of the app is for faster revision purpose. So if you have consider you have an interview tomorrow and you don't have much time and you want to revise all your data structures and algorithm concepts in a very short span of time. So if you want to revise everything, so you can use the app, click back and next button quickly and go through the code once and you can clearly understand how the working of the code, and it will be a quick revision for you before going to the interview. Okay, so let's get back to the topic. So we have implemented stack using linked list in a previous video. Now we have functions like is stack empty, peak stack, and stack top, and is the stack full. So let's see these functions how it's implemented. Now let's start clicking on next. So we have hash include stdi.h, then we have hash include stdlib.h, then we have type def struct node. So we have a struct node. In that we have int data member variable, and then we have struct node next pointer, and we have renamed struct node with capital N small case ODE. Then we have top of stack pointer equal to null. Then we have defined push function. We have declared push function. Then we have peak underscore stack function declaration, stack top function declaration, is stack empty function declaration, is stack full function declaration. Then we have int main. Inside that we have is stack empty. That is the first function that is called. So it goes to that function, is stack empty. If so it checks if top of stack. So it checks if top of stack equal to null. So right now it is equal to null. So it is true. So stack is empty. So that is what is printed. Then it comes out of the function. It goes to push off. So it goes to push off 10. So 10 data is pushed. So it goes to push function. A new node pointer is created. A new node is allocated with a memory of size of a node with typecasted with node pointer. So we have memory allocation at address hash 100. So you have a convention here. The stack data will be in this part, next node address and node address at the bottom. So this is a typical stack node. Okay. So then if new node equal to null, new node is not equal to null, it has been allocated with the proper memory. Had there been not been any memory available in a heap where this memory is allocated, right? If there is no memory available in heap, this would have returned null. So if it had returned null, then we would have observed a stack has overflowed or no space available for implementing stack. Okay, now now we have memory, so it comes out to the else part. So new node data equal to insert data. So new node data will be assigned with value 10. So 10 has been assigned. New node next equal to top of stack. So new node next equal to top of stack. Top of stack right now is null. So null has been assigned for next node address. You can see new node next. Okay. Then top of stack equal to new node. So now top of stack will be pointing to this new node. Then it comes out of the if condition, comes out of the push function. Now again push of 12, so push of data 12, so goes to push of data 12. Now we have new node pointer. New node is again allocated with memory hash 200, so that is the location of that memory. Then we have new node equal to null, no, false, so it goes to the else part. New node data equal to insert underscore data, that is 12 is inserted. New node next equal to top of stack, so new node next will be this part is assigned with top of stack hash 100, so hash 100 is pointing to that. Top of stack equal to new node, so top of stack equal to new node. Comes out of the else condition, comes out of the push function. Then push of 122, so it goes to push of 122. The new node pointer is created. New node is equal to it is assigning a new memory location, so we have hash 300 allocated. So again it checks new node equal to null, false, so it is not equal to null. Comes to the else part. New node data equal to inserted data. Now push of 122, so 122 has been inserted. New node next equal to top of stack, so new node next is this part, so it is assigned to top of stack, so assigned with the top of stack. Top of stack right now is at the location hash 200, hash 200 is assigned. Top of stack equal to new node, so now top of stack equal to new node, comes out of the else condition, comes out of the push function. Okay, and then we have is stack full, so that checking is done, so it goes to is stack full function. Now dummy memory is allocated to new node pointer, so new node we have a dummy memory allocation, so you can see a new node dummy memory is allocated. If new node equal to null, if it was not able to assign a dummy memory, so this memory is allocated from the heap, right? So using malloc, so this memory location, if the heap was full, so it couldn't have allocated memory for a stack. So for this implementation, it couldn't have allocated, it should have returned null. In that case, the stack would have been full. But right now, it is able to assign a memory. So it goes to the else part, stack is not full is printed. Then this is a dummy memory which we are just trying to check for stack full. So we have to release this memory. If you don't release this memory, it will lead to a memory leak. So that is why we do a free of node, new node. Comes out of the is stack full function. Then we have stack top data we try to access using the function stack top. So goes to the stack top function. So you can see stack top. Stack top we have top of stack not equal to null, true. So top of stack right now is pointing to this node, right? So top of stack is pointing to this node, so it is not equal to null, true. So we go in return top of stack data, so returns the data 122, so goes to this. So we have stack top data 122. Then we have peak data, goes to it peaks the stack for the location 2, so it goes to the peak stack int location, so it location 2. So we have a node iterator equal to null, node iterator equal to top of stack, so node iterator equal to top of stack. Then we have for int I equal to 0, 0 less than location minus 1, so location sent for this peak underscore stack is 2, so 2 minus 1 is 1, so 0 less than 1 is true. And node iterator not equal to null is true, so node iterator right now is pointing to this node, so it is not equal to null, it is true. So node iterator equal to node iterator next, so node iterator is pointing to the next node, so this node. If node iterator then again I is incremented, so 0, so just going back, click on back, so we have 0 less than 1 true, then we click on next, I is incremented to 1 now, 1 less than 1 is false, and node iterator not equal to null, that is true, but we have and here, so comes out of the for loop. Then we have if node iterator not equal to null, so node iterator not equal to null, true, it will return the node iterator data. So this was the location 2, right? So it is sending you the data 12. So you have to go, you have to start int I equal to 0 and then go to iterate till the location -1. So then it goes to the location we want. So it returns the node iterator data. So peak data will be 12. So that is what we expected. Okay, then we return from the main function, return 0, returns from the main function. The time complexity is order of n. So the time complexity is the size of the stack. So if you want to access any like the first node or the last node, or so you have to go through all the stack data. It is the implementation of a singly linked list, right? So time complexity is order of n for accessing the data. And if you want to have want access to this code and want to add log and check it for yourself, please click on the code button. Sorry, if you want to access the code, so you have to click on the code button at the bottom of the app. You will get the access, and it is available in the app. I once again repeat, this Robominions.in AI interview prep app. So it's available in the website Robominions.in. Click on download latest version and download for Windows, and then click on download anyway. And signing up, Dhananjai Sharma,
founder of Robominions.in. Don't forget to subscribe to the YouTube channel, share with your friends and family. Visit Robominions.in website, crack your toughest coding questions and tech interviews by downloading latest version of the app, and make your coding easy. Thank you for watching this video. Bye.